Warm welcome to all of you. My today's presentation topic is physiochemical properties in relation to biological action. So now let's start it. The prerequisite of today's presentation is to provide understanding of principle of medicinal chemistry. So it is necessary to consider the physiochemical property used to develop new pharmacological active compound and their mechanism of action and their drugs metabolism and the importance of histochemistry in relationship to or in relation to biological activity. It is very important to get understand that these things. So, objective of today's presentation is to understand various physiochemical properties and their relationship to drugs biological action. And so, let's study it. For the understanding of various principles in medicinal chemistry, it is necessary to understand physiochemical properties and their impact and their aspects in relation to biological activity of any compound or drugs. So these are various parameters that have impact, like solubility, partition, coefficient, dissociation constant, hydrogen bonding, ionization drugs, and redox potential, complexation, and surface activity, protein binding, bioisosterism, and isosterism. So these are various parameters we are going to learn, each one. So basically, they have a high impact toward a biological activity or development of any compound, and their modifications. So now let's start with the first parameter, that is the solubility. I think you all were aware with this solubility. Solubility of any substance or any compound at the given temperature is defined as the concentration of solute, dissolved solute, which is in equilibrium with the solid and solvent, that is called solubility. Solubility depends on various factors like nature of solvent or solute, and as well as temperature, pressure, so these are the various factors that impact the solubility of any compound. Similarly, some of your compound have a high solubility in aqueous solution, and some of compound are dissolved in a liquid organic phase. Those compounds soluble in aqueous solvent, we call that compound hydrophilic substance or compound. And similarly, those compound having solubility in organic solvent or lipid solvent, we call those compound hydrophobic compound or lipophilic compound. So similarly, this solvent molecule or atom form various bond with drug or compound. This bond, you can classify these bond or types of bond into a different category depending on their formation, like hydrogen bond, dipole bond, ionic bonds, and etc. These are various bond that form within a drug molecule or solvent molecule. So another forces that involved in the solubility, that is a solvent bond force, and a solvent solute interaction forces and solubility, etc. Now comes to the next, that is a method to improve solubility of drug. First technique, that is structure modification. In this technique, basically you just have to employ or you just have to replace or modify the certain group or moiety that is responsible for the certain activity. After the replacement or modification, you will get some improved solubility of your drug. So now comes to next technique, that is use of co-solvent. Various co-solvent available for in a market. You can use like ethanol, sorbitol, polypropylene glycol, polyethylene glycol. These are solvent variants that is used or that is employed to improve solubility of drugs. And another thing, that is employing of surfactant. In this technique, basically this surfactant used to reduce surface tension between two compound or two solvent. So you can adapt this technique also. Fourth one, there is a complexation. You can also use this technique. In this technique, basically you just have to use deep block elements, various metal that form a complexes with a drug or solvent that allow your drug to soluble more in a particular given solvent. So now comes to next, there is importance of solubility in respects to biological activity of any drugs. So solubility concept is more important to pharmacists because it governs the preparation of liquid dosage form, and the drug must be soluble before it is absorbed by the body to produce a certain biological activity. है So drug must be in a solution form to interact before its interaction to particular receptor. So now comes to the next slide. So now let's talk about the next parameter, that is ionization of drug. I think you all were aware with this, that the most of drug that is available in our market are either weak acid or base. It can exist in ionized state or unionized state, depending on their consistency. So the ionization basically it means that the protonation or deprotonation that result in charge of drug molecule. So the ionization of drug depends on two factors, that is pK or pH. pK that means the dissociation constant, and pH that means potential ions or potential hydrogen ions. So basically those drug having a more pH or strong acid, suppose, that means their pK will be more, or those drug that is a weak in nature or weak drug, that they have a pK value less. So so the rate of absorption is directly proportional to the concentration of drug at absorbable form, but not the concentration of drug that is available at the absorption site. So ionization of form, or you can say the ionization form, impart good water solubility to the drug, which is required for the binding of drug with receptor, a particular receptor. So you can say that the unionized form help the drug molecule to cross cell membrane. For example, biovitric acid inactive because it is a strong acid, but its substitution, that is a 5,5 substitution or 3,5 di substitution. Biovitric acid has a CNS depression activity because it easily cross the blood-brain barrier, and that is called triple B, because it has a more, or you can say the more pH or less pK value, because of that it easily penetrate to the CNS. So we can summarize this ionization process into two categories. Those drugs already have an ionized state, or those drugs that have already an ionized state. So when they come in contact with aqueous solution or in our body's solution, it forms conjugated acid or conjugated base. The only difference is that the unionized drug, that is a form conjugated base or conjugated acid, having charges on them, their moiety, like just conjugated acid having a positive charge, conjugated base having a negative charge on them. So similarly for ionized drug, that when it come in contact with the aqueous solution, it form conjugated acid, conjugated base. The only difference that the conjugated base don't have any charges on their moiety. So according to Henderson-Hasselbalch equation for the acid, pH minus pK, you can write it as a log ionized divided by unionized drug. So for the base, you can as it you write it, just opposite the unionized drug up and down. For the percentage ionization, you can calculate, or you can use this equation like 100 divided by 1 plus 10, that is pH minus pK. And similarly for drug that have a 50% ionized state, that means the pH will be directly proportional to the pK, and that means their pH or pK will be equal. For example, acid solution of weak acid, that is aspirin in stomach, that have a pH 1.0, will get readily absorbed because it is in unionized form, and that is 90%. So it will easily absorb from that particular area. So the next example, that is a phenytoin injection. I think you all were aware this. The phenytoin is an anticonvulsant drug, and its pH must be adjusted to 12 with the help of sodium hydroxide solution to get up to 99.98% of pure drug in ionized state or ionized form. And in a similar case, that is a topicamide, that is a anticonvulsant drug, and its pK value is 5.2, and its pH must be adjusted to 4 with the help of buffer solution, and to obtain more than 90% ionized state or ionized form of topicamide. So what are the importance of ionization of drug in respect to biological activity? So the weak acid at the acid range or acid pH range, more likely to lipid soluble because it is a uncharged form, or that is a more readily passed through the biological membrane, or triple B, that is called a blood brain barrier. So suppose your drug is having a conjugated acid charges, or already they are in a conjugated acid form or acid or base form, they will get a charge or opposite charges from aqueous solution in our body, and they form unionized form, or that is you can say the unionized form have a more ability to cross triple B or blood-brain barrier. In a similar case, the weak base, that is at the alkaline pH or alkaline pH range, more likely to lipid soluble, because it is an uncharged form, or this form able to cross our biological membrane because of uncharged form. So suppose your drug is already in ionized form, it will get opposite charges from aqueous solution in our body, and they form anion unionized form, or unionized compound. This compound has a more ability to cross CNS or triple B, so it will show more activity or more potential in CNS and other important part of our body. These are the references. You can use these references for more study. And thank you very much to all of you.